All right, I want to go ahead and actually take a look at the practice exam. So here we go. We've got a buggy. It starts at a position 200 centimeters and moves backwards at 40 centimeters per second. We want to write down its position as a function of time and ask a couple of questions after that. So first thing, when we're writing down equations of buggies, I want to just review something. The buggy lab equation that we came up with, okay, just to recall, this was a linear equation that describes the position as a function of time for the buggy. Okay, now we're not going to use, okay, so it's not y equals mx plus b, and I don't want to see you writing y equals, in this case, negative 40x plus 200. Okay, that's not how we're going to do this. Instead, let's be careful. We know the starting position is the y-intercept, and that the slope is the velocity. So when we put that idea together for part A, okay, for part A, x, the position as a function of time, is going to be negative 40 times t plus 200. For part B, what is the position of the car after 6 seconds? Do not try to do anything clever with graphs or imagining a buggy. The whole point of the equation in A is that you're able to actually just plug in 6 seconds and get an answer. And in this case, that's going to be negative 40 centimeters. And in part C, the sign of the answer in B means we end up 40 centimeters, okay, behind our ruler. So that's number 1. Now, for number 2, it says suppose the buggy moves forward from the 0 centimeter mark at x equals 60. We want to write down its position as a function of time. Very similar idea. There's going to be x is 60 times t plus 0. Or if you prefer, x equals 60 times t. Now, it says use the equations you came up with in 1a and 2 to calculate the time it takes the cars to meet and the position at which they will meet. It actually turns out if they meet in the same position and at the same time, what's going on here is that these two cars meet in the same place. In other words, x of this blue equation car is going to be the same as x of the black equation car. So I actually set them equal like this. So I will write negative 40 times t plus 200 equals 60 times t here. And what I'm going to do is I'm going to now go ahead and I'm going to add 40t to both sides. And when I do that, I'm going to end up getting 200 equals 100t. So t happens at 2 seconds. That's when they meet. They meet after 2 seconds. Now, where will they meet? Now, where they will meet, x is 60 times t, which is 60 times 2, which is they meet at the 120 centimeter mark. Sorry, that just looks terrible. So again, where do they meet? They meet at x equals 60 times t, which is 60 times 2, which is going to be at the 120 centimeter mark. All right, so I'm going to go ahead and actually take a look at number 4 now. Idea for number 4. Let's just count squares. So let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 squares. So I'll mark this off as 200. This would be 180, 160, 120, 80, 40, and 0. This is x in centimeters. And then here we're going to have t in time. Let's see what we got. So let's see, 1 second, 2 seconds. Let's see. So you know what? Let's just see, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. So this is half a second. These correspond to quarter seconds, each tick of the square. So we want to graph first negative 40t plus 200. So we'll graph the black colored equation first. So we start off at 0. At 1 second, where are we? I'm going to put in 1 here. So negative 40 times 1 plus 200 puts me at 160. Or if you like, we've got a slope of negative 40, right? So at 1 second, I need to go down 40. At 2 seconds, I go down another 40. 3 seconds, I go down to 80. 4 seconds at 40. 5 seconds at 0. And I can actually go ahead, hopefully this isn't a disaster, and I can take this line, and because this thing can be a little bit weird with the graphing, so, yeah, it's being a little weird, so, all right, close enough. Oh, it's awful. I'm going to see if I can get it to at least somewhat line up. All right, this is close enough. This is terrible, but it's the best I can do with this. So now we've got the other graph, 60t. So every 1 second, it goes up 60. So at 1 second, I'll be here at 60. Let me scrap that. So I start off at 0. At 1 second, I'm at 60. At 2 seconds, I'm at 120. At 3 seconds, I'm at 180. And at 4 seconds, well, it's going to be off the graph here. But, yeah, and then 240. So now what I can do is I can go ahead and I can, in fact, draw this line. Ooh, that's gross. See if it, yep, right through here. Now it works. Right there. Now here's what we notice. This intersection point where the cars meet, this point is, in fact, to 120. So what does that tell us? The cars cross at t equals 2 and x equals 120 centimeters on the plot, just like the algebra above. Now, I'm going to be kind of clear here. I worked this out fairly quickly. I'm making a couple of assumptions here that I'm allowed to make, which is I'm allowed to assume that you've got your Algebra 1 down pretty well. So that's page 1. I'll move on to part 2 of the exam in the next video.